Okay, I'm not going to ask the questions on the exams or quizzes the way they have. What they have is they've given you here secant x on the left side, and they've given you some choices. Actually, the last choice I didn't catch in the screenshot. And they want you to figure out which one of these selections below is equal to the secant x. Well, that's kind of a hard question, but it's the only way that they can ask it on WebAssign, because they want you to actually do some work in algebra with the secant x, transforming it. But then how do you know which one's which on this list? The only way to really check it is to go through each one and check if they're equal to secant x. That's a lot of work. So the way I'll ask it is to ask you to take secant x and transform it into sines and cosines or whatever I want you to do, and give you the end goal and ask you to derive from the front to the end. Come on. There you go. I know right away that secant x can't be the first two because the first two don't transform correctly. So the idea always is to take all these other forms, secant, tangent, cosecant, cotangent, and transform them back to sines and cosines. So that's what I did. Secant x is 1 over cosine. The way I remember it is secant starts with an s, so it's the opposite of what I think, because whatever the opposite of what I think is always going to be right. So secant is really 1 over cosine, and cosecant is 1 over sine. So I replace the secant with a 1 over cosine, and I replace the cosecant with a 1 over sine. And when I invert the denominator and multiply, I get sine over cosine. And that's not secant. And I gave you that intermediate step. That's actually tangent, so they're not the same. It can't be the second either, because the second one is just the reciprocal of the first one. It's the first one flipped. And we already know what the first one is. It's tangent, and tangent flipped is not secant. It's actually cotangent. 1 over tangent is cotangent. It also can't be cosecant x because secant x doesn't equal cosecant x. Well, actually, I realized later that it was cut off. But I checked if this cotangent over cosecant is correct. And what I did is I transformed them. Cotangent's really 1 over tangent, and cosecant is really 1 over sine. So I invert the denominator and multiply. And I get, after I convert to sines and cosines, I get cosine x. Cosine x and secant x are not the same. So I figured out whatever was cut off here, it must be by process of elimination the one that's correct. And I only realized at the end that it was cut off and I didn't have the right expression. But that's the way that if you're doing this on WebAssign, that's how you would do it. You'd actually go through each one and check and reason out why it can or cannot be the case. Ugh. I looked at one. Ugh. So I'm going to do a few of these so you see the pattern of what you're supposed to do. And let me skip this part over. I don't want to do this. Actually, I'm not going to skip this over. I want to show this to you. So this is the most famous identity. Sine squared plus cosine squared is equal to 1. And I told you you don't really have to memorize anything else. The reason is because all the other ones can be easily obtained from this one. First of all, if I divide through by sine squared, this becomes 1. And cosine squared over sine squared is cotangent. And I think I forgot to put the sine squared. And I forgot to divide this one by sine squared. So 1 plus cotangent squared is 1 over sine squared. 1 over sine is cosecant. And I just put a little note here. If you're unfamiliar with cotangent x is 1 over tangent x, but it also turns out to be cosine over sine. So tangent is sine over cosine, cotangent is the opposite, cosine over sine. So there's two representations. And these little notes that I'm putting in on the side, they are things I remember. So I may need these identities. I may not, but I may. But I have them in the back of my mind. Let's see. So here's a trick. On all these WebAssign problems that I gave you for this go-around, it seems like I'm using the same things over and over. I'm taking whatever's there, I'm changing them to sines and cosines, and then I get kind of a messy looking monster sitting here. You have a fraction here and a fraction here, and you have a fraction here and a fraction here. What you'll do is combine the fractions on top and bottom. And you'll do that by getting a common denominator. Whenever you have ones can be transformed to cosine over cosine, for example, because I want the bottoms to match. Here I transform the 1 as sine over sine, so the bottoms will match. The idea is that the first step is to combine the fraction on the bottom and combine the fraction on the top. And you're looking at it kind of strange, but courage. Have courage, because just go through the process and say the next step is to combine the fractions on top and bottom. I know it looks messy. That's what happens when I combine them. Now what do? I've got ugly fraction over ugly fraction. Right. Invert the denominator and multiply. So invert the denominator and multiply. That's what I get. So that's what I did there. I inverted the denominator and multiplied. These two are the same. They cancel out. I'm left with sine over cosine. And that's tangent. And see, this is what bothered me, is tangent wasn't one of the choices. It turns out that that guy was tangent, and you might not see that. Otherwise, you'd have to work each one of them out. So what I'm going to ask you to do is actually start from here and end here. You fill in the gaps in between. That fair? How do you do your WebAssign? What you can do is keep clicking it till it gives you the right answer. Then you'll know where you're supposed to go to. And then start from the beginning and end up at the answer. So that's how you can do your WebAssign. I started writing things that I'm thinking in here. I shouldn't have done that. I think, if the idea, when I look at a problem, I think, why are they asking this problem? What do they want you to learn from it? I would think the idea here is that they want you to get familiar with the fact that tangent is sine over cosine, and that they want you to practice doing algebra with sines and cosines floating around. So why ask a crazy list of answers if that's what you want to get? So I don't know why it was done like that, but that was my reaction.